What we've done now is further modified our program, so not only do you include the contact from the drive to prove that the drive is actually running, what we've done is we're using this proximity switch to detect rotation of the motor with a striker attached to the end of the motor. Now, this could be attached to even conveyor belt, gearboxes, mixers, anything, just to detect that there's actually motion and that the equipment is doing its job. What we do now is we actually use timers to detect that motion. So now when we push, you have to hold the push button until the motor is up to speed. It's proved that it's up to speed. When we let go, the motor will run. Now, if the drive shuts off or the motor is restricted from turning or slows down below a prescribed rate that may be for a process, I'm going to simulate this by applying a little bit of friction. What will happen is the motor will shut off. So here I'm slowing the motor down by applying a little bit of friction, and what happens is the motor actually shuts off. You can hear the drive running in the back, but the motor, as you can see, is just not running. Now I can restart the motor. Again, it's running at speed, and now if I say, for example, something happens that the motor stops turning, I'm just going to simulate it by pulling wire off from the proximity switch. The motor instantly shuts off because it detects no motion. This actually is a further layer of protection, or a good way of programming certain processes where motion is critical, and that equipment could become damaged, or if the equipment is broken, it just shuts the whole system down, and then they can look at maintaining or affecting some sort of repair.